Hello ladies and gentlemen, today we're going to look at our next section in Unit 3, which is on compound inequalities. We're going to focus on the OR inequalities today. You're going to want your notebook today, you're going to want a pencil, and you're also going to want your calculator. Your learning goals for this particular video. I can solve compound inequalities containing OR, and I can graph a compound inequality containing OR. Now, what do I mean by compound inequalities? What is that? Basically, a compound inequality consists of two distinct inequalities joined by the word and or the word or. Today we're just going to look at the or inequalities. Tomorrow we're going to look at the and inequalities. So, here's the first problem. These are kind of what they look like. So what are the solutions of t plus 7 is less than or equal to negative 6 or t minus 9 is greater than 5? Basically what you need to do is treat these as two completely separate problems. So, let's solve the first one first. Let's get the answer. So, t plus 7 is less than or equal to negative 6. So, I need to subtract 7 from both sides, right? Cancel out. I'm going to get t is less than or equal to negative 6 minus 7, which is a negative 13. Now, this or has to transfer down, and you put the or there. So now, let's solve this side. T minus 9 is greater than 5. So I'm going to add 9 to both sides. And I'm going to get t over here is greater than 5 plus 9, which is 14. So I have two inequalities. T is less than or equal to negative 13, or t is greater than 14. What you're going to do is you're going to graph that on the exact same number line. So basically, you're going to have two dots on your number line. So I'm going to have negative 13 right here, and let's put 14 all the way over here. So, what kind of dot at negative 13? Well, it's less than or equal to, so we've got to make sure we fill in that dot. There we go. And t is greater than 14, so that one is open. So, which way? T is less than or equal to negative 13. Well, if it's less than negative 13, I know I'm going to have to go this way, because I got to go smaller, right? And smaller is to the left. T is greater than 14, so greater than or bigger values are on the right. Notice how they're going away from each other. That's actually going to always happen about 90% of the time. The way I think of it is this or that. This part or that part. So they kind of have to be separated because the or makes them separated. Now, 10% of the time, they will transfer into what's known as the and inequality. And we're looking at that later. But a majority of the time, assume that they're going to go away from one another. But please make sure you always check your work and make sure they actually do go away from one another. Let's look at problem 2. So I have 3t is greater than or equal to negative 6, or negative 4t is greater than 12. So let's draw my division line for my or. 3t is greater than or equal to negative 6. Looks like I need to divide by 3, right? Because I need t alone. So I get t is greater than or equal to negative 6 divided by 3. That's 2. Now notice, I didn't divide it by negative, so I didn't have to flip the sign at all. Let's keep that or going. Negative 4t is greater than 12. So to get t alone, I got to divide by negative 4. So I'll get t is, oh, wait, I divided by a negative. Got to flip the sign. So I got 12 divided by negative 4 is a negative 3. So, negative 3 is one of my answers, and 2 is one of my answers. At negative 3, it looks like I have an open dot because it's just less than, right? No line underneath. But it is a closed dot at 2 because I have greater than or equal to. Now, let's make sure it's going to go outwards, right? T is less than negative 3. Well, the less than values are on the outside, the left. T is greater than or equal to 2, and the bigger values are that way. So again, just like before, they both go outwards. Not facing in, but going out. Let's try a little harder problems. So I have negative 2y plus 7 is less than 1, or 4y plus 3 is less than negative 5. So, just like last time, draw my division bar here. Let's solve the first one. Negative 2y plus 7 is less than 1. Very first thing I know I need to do, I need to subtract 7. So that's going to cancel out, right? I got negative 2y is less than negative 6. What do I need to do now to solve? Negative 2 times y. Well, I gotta break the negative 2 away, so let's divide it out, right? Because it's multiplied. Flip that around, and I'm going to get 3. Make sure I write my or in the middle of my answers. Subtract 3 from both sides. He's the last person to the party, so we got to kick him out first. Looks like I got to divide by 4. So I get y is less than negative 8 divided by 4 is negative 2. So I have y is greater than 3 or y is less than negative 2. So I have negative 2, I have 3. Looks like they're both open dots, right? Because neither of them have a line underneath. Let's make sure they go outwards. So y is greater than 3. Well, greater than sign, they go that way. Y is less than negative 2. If they're smaller than negative 2, they have to go to the left. They go outwards again. Wonderful, wonderful, wonderful. Let's try the last problem here. So these are a little bit more challenging just because there's more to the problem. That's pretty much the only difference. So I'm going to draw my line here. Let's read our first inequality. 4y plus 2 divided by 5 minus 5 is greater than 3. So, very first thing, I can't touch this guy, right? Because these are all kind of attached to the y. We got to kick this negative 5 out. He was the last person to join this party. So let's add 5 to both sides. We're going to be left with 4y plus 2 divided by 5 is greater than 8. Now I got to get rid of that division by 5. Otherwise, I can't attack these. These are kind of almost in parentheses right now until I get rid of that division by 5. So, multiply both sides by 5. I got 4y plus 2 is greater than 40. 4 is attached to the y by multiplication, so let's subtract the 2 first. Running out of wiggle room here. Divide by 4. Now, 38 divided by 4 is a little different of an answer. That's approximately about 9.5. But we can leave it as y is greater than 38 over 4. So just to keep in mind, that's about 9.5, okay? Let's try over here. So I have 4 minus 3y divided by 6 is greater than 4. So, very first thing, let's get rid of that division by 6. So let's multiply both sides by 6. Those are going to cancel out. So we'll be left with 4 minus 3y is greater than 24. What's our next step? Well, this 4 is the last person to the party, right? He's not attached to y. So he is a positive 4. So let's subtract him from both sides. Be left with negative 3y is greater than 24 minus 4, which is 20. Now we can divide by negative 3. But I'm dividing by a negative, so let's make sure we flip our sign. So I was a greater than, now I'm going to be a less than. And now you're probably asking, well, what's 20 divided by negative 3? Well, we're just going to leave it 20 divided by negative 3. Now, that negative can move up to the top. I recommend it wholeheartedly, just so you don't lose it. I find if kids leave it in the denominator, they lose it a lot faster. To keep in mind what that actual value is, that's about negative 6.6 repeating. Now, let's graph our two lines. So I have negative 20 over 3 over here, because it's a negative value, right? And then I have 38 over 4, which is approximately 9.5. Negative 20 over 3 is an open dot, right? Because we're at less than. And then we're at an open dot on this side. Well, let's look here. I have y is less than negative 20 over 3, so less than is to the left. Y is greater than 38 over 4. If it's greater than, it goes off to the right. So, just like last time, my OR inequality is splitting off. And that's the end of this video. See you later, Sabers!